This video will be going over section 4.5, which is on logarithmic properties, also better known as log rules. So this section where it's just a few problems to practice the log rules that we're going to talk about. I'll start by talking about the log rules, and then the two ways to practice them are how to bring many logarithms together as one, and how to basically do the reverse, how to take a single logarithm and break it apart. Right. And this section is very, very useful. The reason it's probably the most useful is it tells you what you can do with logarithms. In the end of the last section, not the last section because that was the graphs, but 4.3 at the end we did some logarithms with the change of base in our calculator, and then we talked about how you can do some things by hand without a calculator. This is pretty much the only other things you can do with logarithms. Right, so the few properties I have here, the preliminary thing, if b is greater than 0, b does not equal 1. Those are the rules we have for the log base. And if x and y are both positive, right, that's because the inside of a log needs to be positive, then the following properties hold. Right, the first one says log base b of x plus log base b of y equals log base b of x times y. Right, so that's the formula. The thing I really like to remember, and I usually emphasize, is addition on the outside. We're adding logs on the outside becomes multiplication on the inside. Right, so we take, if we're adding logs on the outside, we multiply the insides together to bring them together as one. And another thing you'll notice is the base doesn't change. The reason, probably the best reason or best way to think about the change of base formula, it's called that because it's the only formula that the base will change. All our other log rules, the base stays the same. And the second one is very similar. The difference is we have subtraction, so log base b of x minus log base b of y, and subtraction on the outside becomes division inside. We get log base b of x over y. Right, so the thing in front of the minus goes on the top of our fraction, the thing behind the minus goes on the bottom. The last one, I'll draw a little visual here. It says log base b of x to the r power. So x to the r, x and r don't need to be b at all. It equals r times log base b of x. All right, so the thing you really want to remember here, I have it in words, but it's pretty much telling you you can move an exponent out front. If the whole inside of the log is raised to some exponent, you can move the exponent out front. And you can put it back in if you need to, meaning if you can't have a number out here, which we'll see problems like that, you have to move it back up, back inside. Right, all these rules are equal signs, meaning you can go from the left to the right side, but we will also go from the right to the left side. We'll practice both ways. But these are the three log rules, and I highly recommend not only writing down the formula, but really writing down the wording. And on top of that, you'll see when we do the problems, it's pretty much what I'm going to be saying when we go through them. I'm not going to write down these rules. I'm going to say the words to get us through it. All right, so one thing that I also like to mention here, many people like to try to do log rules that aren't real, and these are the most common ones. If you are adding or subtracting inside a log, that's it. All right, so if you have like x plus 1 or x minus 1 inside of a log, that is simplified. You cannot simplify or change that at all. So addition and subtraction inside cannot be broken apart. Right, there is no log rule for it. There's nothing you can do to change it. Right. Now that's more of an important thing because Like I said, what typically happens, especially in the next section when we solve equations, is people want to break this up. If you have like x plus 2 inside and they just want the x inside, you can't change it. It's going to be x plus 2 the whole time. Right. Now, the first thing we're going to do is how to bring many logarithms together as one. I'm going to just scroll down very quickly to the problems and then look back up at the steps that we'll take here and kind of explain them along with the rules. All right, so the directions will say something like this: simplify this, and what it means by simplifying is enter the result as a single logarithm. All right, so this one we have 2 and we just want 1 with a coefficient of 1. What that means, coefficient, that's the number out front. We want only 1 out front, or visually we won't have a number out front. So only 1 log with no numbers out front. And once again, I know for this class, a lot of this stuff in this section, in this chapter, is a review. So if you've seen this before, you can, maybe try to do these and then compare to the answers that we get. But to go over the steps, one of the things you have to make sure you're doing, if you're using rules 1 or 2, if you want to bring them together, so if you have plus sum of logs or a difference of logs, you'll notice that there's no numbers out front, or more specifically, all the coefficients are 1. So when you use these rules, your coefficients have to be 1. If your coefficient's not 1, that's when we use rule 3. Right? We take the coefficient, which is represented by r here, the number in front, that'll become our exponent. So you'll see that in my rules outlined here. Bring any coefficients up as the exponents using property 3 that I have numbered. And then once you move all those, you can bring all the logarithms together as 1 using rules 1 and 2. And we'll have one example with 3. That way you can see how we can do 3. But most of them are just 2. You'll also notice that the log bases in these problems are all the same. That's really when you can use these rules. Right, but we'll go ahead and get started with this. Right, so we want to bring log base 6 of 11x to the 5th plus log base 6 of 2x cubed to 1. The first thing to notice is both coefficients are 1. I'm going to actually write them in here. Normally I wouldn't, but both are 1, which means we can already bring them together. Right, so I'm going to go ahead and write that down. Both coefficients are 1. If you have -1, of course, that's fine because that's subtraction. But that is something you'll have to check for. Oops, can bring together. Right, and the way we bring together, well, I have an addition here. Addition outside becomes multiplication inside. Let's go ahead and write that down. Right, so that's what I remember. I do not remember the specific formula for really anything for logs. I remember the wording. It's very, very helpful. And for those of you that are going to take calculus, there's a lot of formulas that you learn in that class that would be absolutely impossible to learn if you try to memorize formulas. You just memorize the wording of them. So it's good practice. But let's go ahead and do that. So we've got log base 6, right? The base doesn't change. And we multiply the inside. We got 11x to the 5th times 2x cubed. Now, once you're here, if you have any common terms, just simplify. Sometimes we will, sometimes we won't, and that's all right. 11 times 2 is 22. And x to the 5th times x cubed, we add the exponents, we get x to the 8th. And this is our simplified, fully simplified final answer. We have a single log, the inside simplified, and the coefficient is 1. right, so moving down to number 2, we want to do the same thing. We want to combine these logs into 1 with a coefficient of 1 out front, and we have 5 times log base 4 of x minus 6 times log base 4 of y. Right, what you'll notice here is the coefficients aren't 1. What you want to do is move them up as the exponent. That is a necessary step. You cannot combine these with coefficients out here except 1. So we move the coefficients up as exponents. And please, please, please do this one step at a time. These problems take 2 or 3 steps at most. If you try to do all this at once, typically what I find is, that's when mistakes are made on these type of problems. All right, so we move the 5 up to the exponent on x. We got log base 4 of x to the 5th minus, right, I'm only moving the 6, I'm not moving the minus, log base 4 of y to the 6th. And now, once you've gotten rid of the coefficients, you can always do that in one step, no matter how many there are. You can always get rid of all the coefficients. Now you can combine them. And subtraction outside is multiplication inside. Well, I said multiplication, and that's clearly going to contradict what the rules are. Subtraction outside is division inside. All right, that's rule number 2 up here. My apologies. Subtraction outside is division inside. All right, and the order of division matters. Make sure you do it in the correct order. The log base doesn't change. We get a fraction. What comes before the minus sign, the x to the 5th, is what goes on top. And what goes after the minus sign on the inside, the y to the 6th, is what goes on the bottom. So once you fill that out, though, you are good to go. All right, and we got x to the 5th on top. We got y to the 6th on the bottom. These things have no common terms because x is not in common with y. You can't do anything with the exponents. This is simplified. This is your final answer. We have 1 log, its coefficient is 1. The inside is simplified. And they pretty much all work like that. I wanted to definitely do one where there is a number inside. It doesn't work any differently. But I feel like with these kind of problems, things with letters are mostly what's stressed, and especially when you go to calculus, you'll see things like this. You're going to have almost nothing but numbers in them. Let's go ahead and do what we need to do here. If we want to combine these two, 3 log of 8 plus 2 log of x, we got to move our coefficients up as the exponents. Before we can combine them, that must be done. We got log of 8 cubed plus log of x squared. And I think one thing that's really easy to do when you have numbers here is just look at this too quickly and maybe do it backwards and put 3 to the 8th power. So just be careful. The coefficient becomes the exponent. And then once we move our coefficients to the exponents, addition becomes multiplication inside. And we got log of 8 cubed times x squared, multiply the insides. And at this stage, the only thing you'd want to do to simplify is figure out 8 cubed, which ends up being 512. So it ends up looking very similar to number 1 in nature because of the numbers and the exponents, even though it started off looking very different. Right, but that's how we deal with numbers. Right, now number 4 here, number 4 is just doing one with 3. When you do one with more than 2, the first step never changes. You always move the coefficients inside. And fractions, you can have any number as its coefficient. You got to move the coefficients inside as exponents. Right? It doesn't matter how many there are. I'm doing the same thing we did for the previous 2 problems. And I'm not touching the minus sign. Some of you may have learned this before and you move the minus sign with it, which is fine, but I don't like to do that. Okay, so the first one we got log of x cubed minus log of y to the 5th minus log of z to the 1/2. Right. Same first step, no matter how many there are. There could be 100. You will not see that, of course, but even if there were 100, the first step would be moving all the exponents or coefficients into the exponent. The next thing that I like to do, especially if you haven't done this before, if it's been a long time, some of you might know how to get right to the final answer, but just do 2 at a time, starting from left to right. So let's combine these 2 into 1. And we'll just leave this log of z to the 1/2 at the end. All right, how do we combine these 2 into 1? Well, subtraction becomes division inside. So this first thing we have is log of x cubed over y to the 5th. That almost doesn't look like an exponent. Let me fix that. All right, so the first 2, log of x cubed minus log of y to the 5th becomes log of x cubed over y to the 5th. And we want to make sure we just bring on down the minus log of z to the 1/2. Don't forget about it because it's still part of our answer. Right, but we've got to go one step further. Go one step further because we need a single log and we still have 2. And even though it looks messy because it looks like we have a fraction, we still subtract logs on the outside. We make division of logs on the inside. All right, same rule that we just used. We'll go ahead and look at that. All right, so I'm gonna have a big fraction bar here because we already have a fraction and we're gonna divide. What goes on the top is what was up in front of the minus sign, which is the x cubed over y to the 5th. And what goes on the bottom was the z to the 1/2. Now, because we're going to need to simplify this, we don't like having fractions inside fractions. I'm going to put it over 1. Right, we can always write a fraction over 1. Now, for those of you that have done a lot with this, the thing you do to simplify this into one fraction is you switch the division to multiplication of the reciprocal. Keep, change, flip is what some people know it as. But this is something you should have run into before. All right, so the way it works, if it's been a while, we take our top fraction and we leave that alone. But we switch the division bar to multiplication and we flip the denominator. c to the 1/2. Okay, so we switch from division to multiplication. We change to multiplication. Okay, so this is what a lot of people learned it as that I'm finding. I've never learned this terminology, keep, change, flip, but if it's familiar to you, then you know exactly what I'm talking about. Ultimately, what it says, we keep the top, we change the division to multiplication, and we flip the bottom. Right, but then to finish up, you know, just because it's written as two fractions, we can write it as one fraction. Multiply the tops, we get x cubed. Multiply the bottoms, we get y to the 5th times c to the 1/2. And this is definitely one of those things, especially if it's not new to you and you remember it. But once you work a few problems in the homework, you'll kind of notice a pattern and you might see the answer right away. Now, I really recommend just doing it out. You know, it's not going to take you as long on your own as it took me to do this to show you, but it's important to actually go through the steps of using these rules. All right, so the last thing I have here is very similar. It's got its own specific directions, but for those of you that will take calculus, these are the kind of things you'll see pop up. And it's something that you learn how to do now and then you just don't do it for a while. So I want to go ahead and show you what you're actually going to use this for. We want to simplify the following expression to a single log with no decimals. All right. So it's pretty much saying the same thing as before, except I don't want you to type this in your calculator. You'll notice these are both numbers. If you do 2 times natural log of 4 minus 2 times natural log of 8, your calculator will give you a number, but we want to combine them. And first thing to do, if we want to combine, is to move the coefficients as exponents. Right, with single logs telling us to combine, we want to move the coefficients to exponents like we did before. So we do that, we get the natural log of 4 squared minus the natural log of 8 squared. Now what I would do here, it's up to you, the order you do it in. You can combine them now, or since these are both numbers, you can just simplify the numbers. 4 squared is 16 and 8 squared is 64. All right, but once you're at this step, you have to do the combining into one. There's nothing else to do, and subtraction becomes division. Subtraction outside is division inside. All right, so we divide at the inside, we got 16 over 64. And if you simplify this, 16 and 64 kind of go perfectly into each other. You can cancel 16 out and get 1 and 4. This is the natural log of 1/4. And this is the final simplified answer. And this is a single log with no decimal. You type in natural log of 1/4 in your calculator, you'll definitely get decimal, but this is our answer. Okay, so that's something you'll actually, a lot of you that will take calculus will actually use this for. Now, another thing that is less common in this class, we will use this stuff in the next section as well, bringing logs together as one. We don't do much of this in this class, breaking a single log up. However, it is something you do in calculus as well. And ultimately, this is a pre-calculus class. That's our goal, is to try to get you more prepared and ready for calculus. And want to talk a little bit about that. We have 3 examples here. How to expand a single logarithm. So I'll just look at this first one here. Really, the process of this is the reverse of what we did before. Okay. So if we wanted to expand log base 3 of x to the 11th times the cube root of y to the 4th, the process we would take is exactly the same. I'll just go to the second one here. Imagine we're starting with this and we want to go backwards. Well, we kind of do all the steps in reverse. If you have a fraction, we want to break apart the fraction. You won't always see a fraction. You can skip that if you don't have one. But I just like to do it in this order. Break apart the fraction. Right? Division inside is subtraction outside. Then break apart any multiplications you have. And multiplication inside will become addition outside. That'll be our first step with this one. And then the last step, because what we're going to want to do is write our forms with no logarithm of a product, no multiplication, quotient, no division, or no power, no exponents. You're going to have to move the power out front. All right, so I'll leave the steps in view as we do this first one, but like I said, there's no fractions here. We are not going to do anything to try to split up a fraction. But we do have a multiplication here to split up. We got x to the 11th times the cube root of y to the 4th. Now we do have multiplication and we want to split that up. Multiplication inside is equal to division outside. Wow, I keep saying the wrong thing. These people outside are talking very loudly. Multiplication inside equals addition outside. The multiplication inside is addition outside. We get log base 3 of the first thing we're multiplying, which is the x to the 11th. I did not write that. Don't want to block your view. Log base 3 of x to the 11th. Because it's addition outside, we've got plus. And then we get log base 3. And the other thing we're multiplying is the cube root of y to the 4th. All right, now that we took care of steps 1 and 2, for step 1, we didn't have any fractions to worry about. Step 2, we broke apart all the multiplications. You'll notice there's no more multiplications. All we have are exponents. And I'll remind you, we've seen this a few times in this class now. Anytime we have a radical, it's a fractional exponent. The cube root of y to the 4th is the same thing as y to the 4/3 power. So I'm going to just plug that in first and not try to do both in one step. All I'm doing is changing it to an exponent so it looks more like our rule we're going to use. Right, but once we get there, now you can move the power. Okay, we can move the power 11 and we can move the power 4/3 out front. And that'll get rid of everything. So we'll have 11 times log base 3 of x plus 4/3. Let me make a multiplication. Times log base 3 of y. Right, but that satisfies all our rules. And the inside of the logs, we don't have any multiplications, we don't have any divisions, we don't have any exponents besides 1, but that's never going to go away. We are done. Now, one thing I like to go ahead and mention here, you could ask the question, why didn't we move the powers first? Now, the reason you can't move the powers first is because that rule number 3 only works if the entire inside's raised to the same power. That's why we have to save it for last. We cannot move the power or the exponent out front unless the entire inside is raised to that power. Right, and the two things we have here, the x and the y, are raised to different powers. One's raised to the 11th power, one's raised to the 4/3 power. Okay, but I'll scroll up to show you that rule one more time. If we want to use this rule from left to right, what it's saying here, the entire inside just being represented by x is raised to that r power. Number 2, the second example I have here is just one where there is a fraction, but we want to break apart fractions first, right? Fraction or division becomes subtraction outside. The reason I like doing it in this order is it just follows the same procedure every time. Okay, so what we are thinking about here is doing that division rule in reverse. If we make a subtraction outside, what goes in front of the subtraction is what's on the top, x to the 11th times y to the 20th. We get our minus, and then we get the natural log, right, same base and everything, of z to the 12th, what's on the bottom. Then we ask ourselves, are there any multiplications inside? And there's one in the first one. There's no multiplication in the second one. But while we do this step, this isn't going to change. Multiplication inside, once again, becomes addition outside. And from this first term, we'll get the natural log of x to the 11th. This looks a lot like the first problem we did, plus the natural log of y to the 20th. Right? These two see if I can underline it more color coded. The natural log of x to the 11th times y to the 20th equals the natural log of x to the 11th plus the natural log of y to the 20th. And we're just leaving the natural log of z to the 12th alone for the time being. Right, but once you do those first two steps, you take care of all the divisions, you take care of all the multiplications, which we have now. There is no multiplication or division inside. We move the powers out front, and then we are done. But you have to wait until this step, until the entire inside is raised to that single power. So we get 11 times the natural log of x plus 20 times the natural log of y minus 12 times the natural log of z. Now the last one is more like the type of one you would see in a calculus class. This is something that you would have to do something called the derivative of. You may or may not know what that means, but doing it the way it's presented is basically impossible as far as how complicated it is. But if you split it up like this, it becomes a lot easier. So that's why I wanted to go ahead and just show you how to do that first step of splitting something like this up. But we don't take any different approach that we did to number 1 or 2. We have a fraction inside, we split up the fraction. It becomes subtraction outside. So we get the log base 2 of the top minus log base 2, keeping the same base, of the bottom. All right, now one thing I want to point out here before we go to the next step is that this second term here, this is already simplified because we cannot split up over plus and minus. So this thing is actually going to be a part of our answer. We just need to simplify the first part. That's what I talked about at the very beginning of the two things you cannot do. You cannot split up a plus or minus inside a log. Right? There's no powers here. There's no multiplication of things. 3 times x, yeah, but that's just 3 times x. It's not like x times y or something. So this is already simplified. We need to simplify this part. And inside this one, we do have a multiplication. That's what we need to break up. So after we take care of the fractions, we take care of the multiplications. Multiplication inside is addition outside. So the first two terms, when we split up the multiplication, we get log base 2 of the first thing we're multiplying, x to the 4th, plus log base 2 of the second thing that's being multiplied, which is the square root of x minus 1, and then minus log base 2 of 3x minus 14. Right, at this step, you can simplify it all the way. We didn't rewrite the radical. No, if you want to go ahead and do that, I'm not going to write all this down again, but I will remind you that the square root, there's that invisible 2. We are raising to the first power out here. So this should be in parentheses if we're thinking about raising to the first power. This is the same thing as x minus 1 to the 1/2 inside. So now we can move the exponents out front to finish up. Okay, so we take the 4, we move it out front. We got 4 times log base 2 of x. We take the 1, I don't know why I keep writing by accident. Take the 1/2 here, the exponent. Now we move that out front. We got plus 1/2 times log base 2. The inside is x minus 1, and remember that is something that cannot be changed. And like we talked about at the beginning, or a little earlier, the second part's already simplified. There's no exponents to move out front. There's no multiplications. There's no divisions. Just log base 2 of 3x minus 14. Right, but that is this section 4.5 on logarithmic properties, just helping you get a little more comfortable with using these rules. And like I said at the beginning, the order I did all the things in here is the order you have to do in. If you don't do them in the right order, then you end up breaking a rule. Right, so for the bringing the logs together as one, you have to break it apart before you move the exponents, like we talked about. And for bringing the logs together, you have to move the coefficients inside as exponents before you implement your rules on how to combine them.